Welcome to Financial Management, Chapter 2, where we're going to look at time value of money. So this chapter basically focuses on how that the money tomorrow and the money today, money in hand now is worth the kwacha tomorrow. So the kwacha that you have now is worth more than the kwacha tomorrow because of concepts like what? Interest rate. So we're going to look at the concepts of future value, present value, how we compound versus discounting, how to look at annuities and perpetuities and the effective interest rates. So basically, um, this is what we have in this chapter. Before we look at the questions that are there, maybe just to take you through the concepts of each of these ones. Sure, you have learned through at your own time. Um, the future value basically looks at what? The value you expect tomorrow. It's given by present value times 1 plus r to the power time. So future value, if you have it 1,000 kwacha, after 3 years, we just calculated it. Uh, that you can be able to calculate the future value by using that particular formula. So present value, on the other hand, is looking at what? The money, the current worth of a sum of money to be received in future discounted today. If you expect rentals over 10,000 at the end of 3 years or 3 months, how much it is today will be less because of the aspect of what? Time value of money. So you need to understand how to discount that value. So present value is simply the money with a figure when you discount it now. So it's given by this formula. So if you are expecting 1,300 3 years from now at 10% discount rate, how much is it worth today? So it is future value 1 plus r to the power time. So our interest rate is 10%. So you put it in there. So you're going to get our 1,000 kwacha. So compounding helps you calculate the future value invested today. Discounting helps you calculate the present value to be received in future. So these are two different processes. They work inversely. So one brings the future today, one projects the future tomorrow. So it's the same formula that we are using in different ways. Then we also have the concept of annuities. What are annuities? Annuities are simply a series of equal periodic payments. These payments are made at regular intervals. So the key word is there should be a series of equal payments, but at regular intervals. So we have two types of annuities, of what we call the ordinary annuity and annuity due. The payments that are made at the end of each period is called an ordinary annuity. For instance, like loan payment, okay, or monthly rent, if you are paying at the end of the period, that is called an ordinary annuity. An annuity due is what you pay at the beginning of the period. For instance, insurance you pay at the beginning, lease payments. So the formula for each of these ones is given as follows. The future value of an annuity is payment 1 plus r to the power n minus 1 over r, and the present value of an annuity is given by 1 minus r to the power negative n over r. So suppose we have 1,000 kwacha, okay, like we started with, and the interest rate is 10%. And the time period is what? 3 years. Who remembers how do we find the future value of this figure? If this is our present value. Future value is got what? Present value 1 plus r to the power t. Okay, I want you to get the differences. So it's 1,000, 1.10 power 3. So what did we find here? 1,331. This is how we find the future value. So this 1,000 will jump, okay, from year 0 is 1,000 kwacha. How much will it be at the end of the third year? That's what we're talking about. So at the end of the third year, it is 1,300 and what? 31. Then we have an annuity, future value annuity. This one is different. So it is given by the present value, okay? 1 plus r to the power what? Time, or n, minus 1 over r. So here we have 1,000 kwacha. Our interest rate is 10%, so 1.10 to the power 3 plus 1 over 10%. So if you compute this properly, you're going to get what? You're going to get 1,000 times 3.1,000 multiplied by, do you have a calculator there? You can compute it. Okay, so the graphical representation of that is at 1, 2, 0, 1, 2, 3. So this 1,000, and here there's another 1,000, and here there's another 1,000, and here there's another 1,000. How much would it be at the end of the third year? Okay, for 3 years. Okay, so meaning, okay, this one will remain the same. It will not stay with still 1,000 because this is at the end of the year. And this one, it will stay for 1 year. So 1,000 is 1.1 to the power 1. So here we're going to get 1,100. And this one will stay for 2 years, 1.1 to the power 2. So here we're going to have what? 121. So when you total up this, you're going to get what? 3310. Okay, so 3.10. So this is called the future value of an annuity. Ideally, you're supposed to have a 3,000 kwacha, but because some of the cash flows are having an interest, so it becomes an annuity. So a single deposit that grows to a future amount is just a future value. But a single deposit that is made equally in regular intervals is called an annuity. So this is called a future value annuity. So future value annuity is the amount paid at the end of the period. When you multiply any annuity times 1 plus R, it becomes an annuity due. So this, when you multiply the future value of an annuity, 1 plus R, you multiply by 1 plus R, it becomes the future value annuity due. So the answer we got here, the 310 times what? 1.10. The final answer is called a future value annuity due. Are we together? So this is how we calculate the future value annuity due. Any questions so far? Anyone behind? Are we moving together? Especially the beginners. We covered a lot of this already. Need you to understand because we have quite a lot to cover. Are we following? If it's clear, we proceed to calculating the present value of an annuity. So present value of an annuity, the concept is simply the same, except that you need to understand the formulas that are here in the context on how the questions are brought. So you have an amount of 1,331. And you want to understand how much it is today. So you're simply dividing by 1.10 to the power what? 3. You're discounting it, takes you back to 1,000 watt. This is just a present value annuity. But sometimes you have cash flows you're expecting. So year two, year one, year two, year three. All these have 1,000 kwacha, 1,000 kwacha. So now, ideally, you're supposed to have a 3,000 kwacha, but because you want that money today at 10% interest rate, it will reduce because that 10% will discount those figures. So here you're going to divide 1.10 to the power 1, 1.10 to the power 2, 1.10 to the power 3. So each of these will be discounted. So when you discount all these and you add them up, you are going to get 2,471. This is how we find the present value of an annuity. So this is a formula here. So the present value of an annuity. Any question? Is it possible to share the notes? Yes, I've shared the notes already. Those that have just joined. So the present value here of 1,000 times 1 minus 1.10 to the power to the power 3 was 3 years. The time will be given. Okay. So when you compute that, you're going to have 1,002.471. So when you compute that, you're simply going to get the 2,471. So this is the value of what? Of stock, or the value of the cash flows when you discount them. So this is what we're trying to talk about here. All right. So let's go back to our notes. So question number 1, define time value of money and explain the significance. So time value of money is a principle that money available today is worth than tomorrow. So significance is used in capital budgeting. It's a basis for share and bond valuation. It helps us in computing what? Financing alternatives. So suppose you have a 5,000 kwacha at 8% interest for 4 years. What is the future value? So future value is PV 1 plus R to the power n. So 1.08 to the power 4, we find 6,800. Then you receive 10,000 after 5 years. The discount rate is 12%. What's the present value? So it's future value 1 plus R over n. So this is 1.10 into 10,000. You see the amount is 5,000. What is the difference between discounting and compounding? So compounding is a process of finding a future value from the present value by applying the interest over time, whereas discounting is a reverse process where you find the present value of the future cash flows. So it's a 5-mark question, getting the concept. Then ordinary annuity concept. So find the value of an annuity paying 2,000 annually for 6 years if the discount rate is what? 10%. So here the amount 2,000, 1 minus R, 1 plus R, this is 1.10 to the power negative 6. When you compute this properly, you're going to find the present value of the annuity is what? 8,700. An annuity due, you just multiply the answer times 1 uh, plus R. So the amount that you get, if it was in here, you just multiply this one by 1.10. So here, annuity due. A person deposits 1,000 for 5 years at 12% with payments at the beginning of the year. Find the future value of an annuity. So future value, you see the difference between future value is that the present value, we have negative. The formula is this side. Future value, it is in front and it's positive. So if let's calculate the uh, future value annuity. So here the figures have changed. 10,000 for 5 years at 12%. So you calculate the future value of an annuity is 6,300. Then you multiply this by 1 plus R, which is this. It gives you 7,100. So we're multiplying 1 plus R because it is now what? An annuity due. An annuity due is paid at the beginning of the period. Okay, are we together? So this is very important. It looks easy when somebody is explaining, Like I have emphasized, these questions are repeated from the textbook. So I've compiled all the questions in the textbooks and they're in the pamphlet, but I've also given you the notes for you to go through. So um, we also go through calculation of annuity in perpetuity. So if a preferred share, it pays $5 annually forever. If the discount rate is 8%, what is its value? So we calculate it as follows. The value in perpetuity is um, the amount over the interest rate. So 50 over 0.08, this is 625. This is how we calculate the amount in perpetuity. In fact, this is a formula we also use when we're calculating the value of our preferred stock. So we also have concepts of nominal and effective annual rate. So nominal rate is simply the stated rate without considering compounding, whereas effective annual rate, it is one that accounts for intra-year compounding. So effective annual rate is given by 1 plus R over M, M minus 1. Now this M looks at the number of compoundings. To compound is either to earn or to charge interest. So if it's annually, compounding is once. Semi-annually, compounding is twice. Okay, which is semi-annually. Annually. Quarterly, what is our M? How many times are you receiving or earning interest? 4 times. Quarterly. Okay. Our M is 12 if it's what? Monthly. Our M is 52 if it's what? Weekly. Our M is 365 if it's daily. So you need to understand these compoundings. So we're being asked that the bank offers what? 12% nominal interest with the quarterly compounding. So the key thing is understanding the equal. So here 1 plus our R is 12% and quarterly is 0.4, and here put a 4 there minus 1. So this is called our effective annual rate. If it was saying monthly, we would have divided 12% over 12 and the power 12 there. All right. So this is how we compute the compoundings. So on chapters 1 and chapters 2 only, based on what I have taught you, I will send questions for you, okay, that you should attempt as your homework, and I'll need those solutions. Thank you so much.